All right, looking at some multiplication properties of exponents. First of all, quick term to get out of the way, a monomial. A monomial is a number, variable, or product written all together to seem like one term. So we get monomial, one term. So a couple of rules about multiplying with exponents. If we have the product of powers, that means that when we have the same base, multiplying the same base by each other with exponents, what we're going to do is when you multiply, you add the exponents together. So for example, if we had b cubed times b to the fifth, that's going to be like saying that we have b to the 3 plus 5, also known as b to the 8th. If we have g to the 4th times g to the 6th, that's like having g to the 4 plus 6, also known as g to the 10th. Now, if we have the power of a power, so like see we have b cubed to the 5th power, at this point we're going to multiply the exponents together. So we're going to take b to the 3rd to the 5th, that's like having b to the 3 times 5, also known as b to the 15th power. Having g to the 6th to the 7th is like having g to the 6 times 7, also known as g to the 42nd power. Now, when we have the product, or the power of a product, we're going to take the power of each factor, then multiply it all together. We're going to take the power of each factor and then multiply it together. So if we have negative 2xy to the cubed to the 5th power, we're going to say that we have negative 2 to the 5th power times x to the 5th power times y cubed to the 5th power. So that's like saying that we have negative 32 x to the 5th, y to the 3 times 5, y to the 15th. Now we have a couple rules when it comes to having the when we need to simplify expressions. If we're asked to simplify an expression, we have a couple rules. First thing, we know it's simplified when no variable base appears more than once. Also meaning that each variable as a base appears only one time. Our expressions are most simplified when there's no powers of a power. No power of a power. So there's no power of a power left. All of our exponents are just one at a time. And all fractions are reduced, if applicable. Alright, so if we are asked, get that out of here, that doesn't belong, to simplify the expression 3xy to the 4th squared times negative 2y squared cubed, we are going to get to work. So you always are going to work outside in. So looking at this first term, I'm going to make sure that I do this power of a product first. So I'm going to say 3 squared times x squared times y to the 4th squared. So I'll have 9x squared, y to the 4th to the 2nd, that's 4 times 2, y to the 8th. Now over here, negative 2y, that group squared, cubed, I'm going to work outside in, so I have to do this power of a power first. So I have negative 2y, now to the 2 times 3, which is 6. Now I'm going to do my power of a product and say negative 2 to the 6th power and y to the 6th power. So I bring this 9x squared y to the 8th times negative 2 to the 6th power, I find out is 64 times y to the 6th power. Now I do some rearranging and say 9 times 64 times x squared times y to the 8th times y to the 6th. I just put all my like terms by each other. So I do 9 times 64, which gives me 576. I have my x squared. Now when I do y to the 8th times y to the 6th, remember that's like saying y to the 8 plus 6, so y to the 14th power. So I have 576 x squared y to the 14th power. You just got to remember all these rules, take it nice and slow, and do one at a time. Looking at our practice problems, we're on page 934, looking at 27 through 38. And it says to simplify each expression. So let's see, 27 says we have q squared times 2q to the 4th. So we're going to rearrange to put our like terms next to each other. So I'm going to say 2q squared q to the 4th. Not quite simplified yet because I still have two variables of a base. So I'm going to say 2q. Remember when we multiply bases, we add the exponent, so 2 plus 4. So this is 2q to the 6th. All right, good luck. Take your time. Remember your rules for powers with multiplication.